We have the limit of 1 minus e to the negative x over e to the x minus 1 as x approaches 0. I'm claiming that this limit is equal to 1. We do the direct substitution, plugging 0 in for x, and then simplifying down. So e to the negative 0 is just e to the 0, which is 1. And 1 minus 1 is 0. And we get 0 in the denominator. So that means we need to try to do something with this. And I'm going to end up rewriting this because this is e to the negative x. We can rewrite that as 1 over e to the x. I want to get a common denominator here. We need to try to simplify this down. So by getting a common denominator, I'm going to write e to the x over e to the x, which is just 1. But now we have a common denominator. And 1 times e to the x is just e to the x. So now that I have a common denominator, I can add the numerators. So we have e to the x minus 1, right? And then we just rewrite our denominator. And of course we're rewriting this. Now what I'm going to do is I'm going to take this e to the x and just more or less drop it down into the denominator. Because we have an e to the x minus 1 up here in the numerator and an e to the x minus 1 in the denominator, those will cancel out. And so finally we've got this to simplify down to the limit of 1 over e to the x as x approaches 0. Plugging 0 now in for x, and we get 1 over 1, which is 1. And that's what I was claiming, that our limit was equal to 1. Okay, so we've got the limit of e to the 3x minus 8 over e to the 2x minus 4 as x approaches the natural log of 2. So we do the direct substitution, plugging natural log of 2 in for x. Now, as you can see here, this is written differently by the properties of exponents. We can actually rewrite this as this. And the reason I do that is because e to the natural log of 2 just reduces down to 2. And it's raised to the 3rd power, and that's where this 3 is coming from. But 2 to the 3rd is 8, and 8 minus 8 is 0. And we get 0 in the denominator. So that means that we're going to need to try to simplify this down as much as we can. Now up here in the numerator, this is nothing more than the difference of 2 cubes. And so we're going to use this form right here in order to factor the difference of 2 cubes. And as you can see here, the way I've got it written, and so a is our 2. And so we just use our formula here to be able to factor this. So we got e to the x minus 2. This is our x here, which is represented by the e to the x. The 2, which is our a, and a squared, or 2 squared, is 4. Well, we have an e to the x minus 2 up here in the numerator and e to the x minus 2 in the denominator, so those are going to cancel out. So now we're going to be left with this new limit of e to the x quantity squared plus 2e to the x plus 4 over e to the x plus 2 as x approaches the natural log of 2. So now we're going to do the direct substitution, plugging natural log of 2 in for where there's an x. So e to the natural log of 2, remember, is just 2. Then you have the square here, and e to the natural log of 2 is 2. I should say this 2 here. And of course, after we do the arithmetic, we get 12 over 4, which is equal to 3. And that's what I said that our limit was equal to. Now the key in this problem was remembering how to factor the difference of 2 cubes. So it's going to be pretty important that you kind of memorize this here. It's a whole lot better to memorize